Right now, Casey is eating a sandwich. He's getting ready to go for a run. And as he's eating that sandwich, the teeth chew up the food into smaller pieces, and the saliva breaks down anything it could, molecularly speaking, so that it could be easier to digest. And when he swallows that food, the muscles in his throat and esophagus push that down into his stomach, where digestive fluids such as hydrochloric acid will break down the food, and it can travel through the intestines to be harvested for nutrients and such. Casey has decided to eat some yogurt after eating that sandwich, which will help him get more nutrients and fats for his run. Now, as the yogurt travels down the esophagus into the stomach, it will then go towards the small intestine, where it can be harvested for some more nutrients. Now, since the small intestine is so long, that gives it much surface area in order to absorb the nutrients. And as the yogurt travels through the small intestine, it will encounter many villi and microvilli in which the nutrients can be absorbed. Now, the epithelium, or the outer tissue of the small intestine, is largely simple columnar absorptive cells bound by tight junctions and richly endowed with microvilli. These cells bear the primary responsibilities of absorbing the nutrients and the electrolytes. Now, the epithelium also has many mucus-secreting goblet cells, but between the villi, the mucosa is studded with pits that lead into tubular glands called intestinal crypts. Now, deep in these crypts are specialized secretory cells called Paneth cells, which also fortify the small intestine's defenses by releasing antimicrobial agents. Altogether, the various epithelial cells arise from just continuously dividing stem cells at the base of the crypts. And altogether, this helps the small intestine absorb as many nutrients as it can. After eating, Casey is letting that food sit in his stomach, where it can be processed with some bile, and which is secreted by the liver and held in the gallbladder. Now, the liver and the gallbladder are accessory organs that are kind of associated with the small intestine. The liver has a lot of metabolic and regulatory roles. However, its digestive system function is mainly just to produce bile for export to the duodenum, and that bile works as a fat emulsifier that breaks down the fats into tiny particles so they can be easily digested. The gallbladder in this situation is mainly just to store bile for the liver, and the liver also has some maintenance functions. The bile salts, and to a lesser extent the secretin transported via the bloodstream, stimulates liver to produce bile more rapidly, which helps even more in digestion and more efficiency in the stomach. After all that food has gone through the stomach and the small intestine, it will then travel to the large intestine. Afterwards, it will go through the sphincter of the anus and will be fully excreted from the human body. Now, the large intestine has some functions that include some digestion, where some remaining food residues are digested by some bacteria. It also has some absorption functions, where some remaining water and electrolytes or vitamins produced by bacteria are absorbed. It mainly has a propulsion function, where the feces are propelled toward the rectum by churning and movements by the muscles, and then which ties into this propulsion function is the defecation, where the feces is fully propelled from the human body by rectal distension, and all the excrement that human body does not want has been eliminated from the body. Well, it sounds like Casey's done. Casey has decided to watch some soccer right now, and the images projected on the screen are being processed in the visual cortex of his brain, which is back in the occipital lobe, by going through the eyeball and then being placed into being centered optically into the back of the eyeball, where it can be flipped upside down and then sent up to the brain. And over time, the brain has learned to take that image and flip it upside down so it can be, so the body can be fully balanced when it sees an image. And he's also hearing the game as well, as that sound is going into the outer ear, being bounced around in the outer ear, and then going into the inner ear, where it can be processed and by thousands of little nerves in the inner ear that send signals to the brain so it can be interpreted. These senses listed, both hearing and sight, are part of these special senses. The others include taste, smell, and feel. Feeling or sensation is part of the integumentary system, and the taste and smell Casey experienced earlier when he was eating. Okay. Right now Casey is doing some stretching before his run, and you can see here he's using his integumentary system, which is the skin. Now the outer skin, the epidermis, has hairs and ridge lines on it, specifically on the fingertips, which help create friction so he can touch his feet and his fingers won't slide off. Now below the epidermis there is the dermis, which includes a papillary layer and a reticular layer. Below that you get the hypodermis, which includes some more nervous structures and hair follicles. Well, the hair follicles are also in the dermis, but they can also stretch down to the hypodermis potentially. But mainly in the hypodermis you see adipose tissue and some veins and nervous structures. Right now Casey is stretching out some joints for stretching before his run. Some joints he is stretching out are the hinge joints in the vertebrae, and right now as he's swinging his arms he's using the ball and socket joint in his shoulders. Now the stretching helps stretch out the ligaments, and as it's stretched out, when they repair they become more flexible, which is better for a run or really any physical exercise. Okay. Casey, how do you feel after your run?
I feel really good.
Good. You should feel good, because you just worked out the skeletal system. By running, you have applied some force onto your bones, specifically in the lower leg, which will increase their bone density. And that could also help prevent osteoporosis later in life, so long as you get adequate physical exercise on a daily basis. Now, the bones are composed of a hard, calcified part, and then a softer inner part, which contains a lot of bone marrow, both red and yellow. The red bone marrow mainly serves for the blood cell production, and the yellow stores mainly serve as storage for fats, and in the outer part, it's composed of a lot of calcification and osseous cells. Now, blood vessels do penetrate through the outer part because they need to supply oxygen and nutrients, and they are connected to the bone marrow part through what are called Volkmann's canals. Together, the bones in your lower leg, they would be considered long bones where you work them out. These bones serve mainly to provide function as just support and a lot of protection because specifically in the ribs they protect the lungs from any outside damage. Casey, did you do a lot of heavy breathing when you were running?
Yes, I did.
Did you find it hard to breathe?
I did actually, yes.
Okay. Well, it's good that you were doing a lot of breathing, especially a lot of heavy breathing, because your blood and the rest of your body needs a lot of oxygen. Now when you breathe in that oxygen, it travels down the esophagus and into the lungs, both lungs actually, where the oxygen can be absorbed by the cells in there known as the alveoli, put into the blood, and then travel around through the cardiovascular system. The oxygenated blood will go towards the heart and be pumped throughout the body, will return to the heart as deoxygenated blood because all the oxygen that was stored onto the red blood cells will be used up throughout the body, especially in the muscular areas or other areas that get a lot of use. And as it travels back to the heart, it will be deoxygenated blood, and then it will be returned to the lungs for more oxygen, and the cycle will continue. And just to know that when you breathe in the oxygen, even though it's put into the blood through the alveoli, when you breathe out, you're actually breathing out carbon dioxide, which the body does not need. Hey Casey, do your muscles hurt right now?
Yeah, they feel sore after I ran.
Would you say that generally your whole body's in pain, or do you feel fatigued?
I just feel tired. I wouldn't say it's pain, it just feels sore.
That's good. You should feel tired. A lot goes into any sort of physical movement. For instance, in order to actually get your legs to move, your brain has to send a signal from the cortex that controls movement down to the muscles in the legs. And this is done by sending an electrical signal through one cell along the nerve. And as it passes through, this is done by changes in ion concentration in the cells, specifically the Schwann cells, which are connected by a node of Ranvier. And as it changes very quickly in ion concentration, that produces some electricity. This is known as an action potential, by the way. And as it travels, when it hits each node, then it gets larger, because as it travels along, it gets smaller and shrinks. But when it hits that node, it is stimulated again, and it returns to normal, as it should, in order to be sent down all the way to the muscles. So that's how the electrical signal travels down the nerve. But when it actually reaches your muscles, this produces something we call the sliding filament theory, where the muscles contract because of certain chemicals and other hormones that are activated when an electrical signal comes on, among other neurotransmitters, that cause the muscle fibers to contract and enclose together based on this sliding filament theory. And that's how any of the muscles actually get to move. And all of this